Okay, here we have an airplane flying at a heading relative to the air. We're given information about an observation from the ground and then the direction of the wind. We want to determine the speed of the wind. We've worked enough of these problems so that hopefully you realize, and this also says, that we want to draw out, oops, that's not what I wanted to do. Let's get back to here. We want to draw out complete vector diagram with arrows and label these known quantities. Okay, if you don't have that, then it's very hard to follow what's going on here. So let's write out what we know. Our vector diagram is going to represent the velocity of the plane with respect to ground being equal to the velocity of the plane with respect to the air plus the velocity of the air with respect to the ground. And this is the wind. Okay. So what do we know? We know this information right here is telling us the direction of the velocity of the plane with respect to the air. Okay, 15 degrees west of north. So I'm going to label north and east right here. Alright, I'm not quite sure how these are going to get combined yet. Just working from scratch here. So I'm going to draw 15 degrees north of west as a vector. I'm going to label it velocity of plane with respect to air. Okay. Next piece of information. Person on the ground, so this is going to be relative to the ground, observes the plane to fly at 100 miles an hour east of north. Alright, so let's switch colors here. 100 miles an hour, 30 degrees east of north. So I'll draw that vector in. Okay, I said this was relative to the ground, so that's the velocity of the plane relative to the ground, 100. And that angle is 30. I forgot to, on my first one, label this angle as 15. Okay. Given the direction of the wind as 10 degrees north of east. So how do we add that to these two? Well, we go back to our vector diagram. This is our resultant, so the red one is our resultant. So we're going to have to add that one plus that one, head to tail, to get our resultant. So we've already got plane with respect to air, so we're going to draw the air with respect to the ground, starting here. And let's see, we don't know the length of this vector, so it could be shorter or it could be longer, but we know that the direction of this air with respect to ground is 10 degrees north of east. So there's east, so I've actually drawn it about right. So we know this direction of the velocity of the air with respect to the ground, and we know that angle right there. Okay, sorry, I'm getting a little small. Should have given myself some more room. So let's go back and review to make sure we've used everything. We've got the heading of the plane with respect to the air is our blue vector. We've got the ground information is our red vector. We know both magnitude and angle of that. Okay. And then we know the direction of the green vector. So we've got a lot of information about angles, and we got one side of our vector triangle addition. So let's see how we can finish this off. We want to determine the speed of the wind, so we want to determine the magnitude of the air with respect to the ground, the length of this green vector here. Alright, so now it becomes just a geometry problem. The way I look at this is I know this angle, interior to the triangle, is 45, 30 plus 15. Okay, I see a horizontal reference here, So I actually have a vertical reference here, so that tells me that this angle right here is 90 minus 15. So I'm going to label that as 90 minus 15, or 75 degrees. Alright, so then this plus this is 85 degrees. So let me redraw things just to sort of clarify. We have a triangle. We have 45. Now we have 10 and 75. So we know, and we know this side is 100. Okay, so we're about there. We want to just erase this and write it in as 85 to make it a little bit cleaner. So we could use law of sines, law of cosines. Law of sines in this case is going to be quicker. I know this side, that adjacent angle. I know I want to find this side, and I know its, opposite angle, and I know its opposite angle. So we could write law of sines right here. Sine of, I'll do it this way, x over sine of 45 is going to be equal to 100 over sine of 85. Writing it out this way and taking the time to find the quickest way to the solution helped us out a lot, gave us a very easy equation to solve. Okay, so we will have 100 divided by sine of 85 times sine 45. Oh, let's see, it's not listening to me here. 100 not sure why it's not. Okay, there we go. 100 divided by sine 85 times sine 45. 70.98, or 71. So the magnitude of that side was 71. That is the velocity of the air with respect to ground. It's going to be, units right here were miles per hour, so it's going to be miles per hour. And that's all we need to do, determine the speed of the wind. 71 miles per hour. Key to these problems is right here. Getting a good diagram. Make sure we've labeled everything. I believe we have, with the unknowns and the names and the known values.